Hello everyone, my name is Markus Pardede and I'm a student robotic engineering of Polytechnic Negeri Batam. My name on 42222201063 and I'm here to presenting about my assessment mid-semester on module Computer Vision RE604. Okay, let's see about my load data. All right, you can see in this screen. This is my load data visualization on the first. So in this first step, I load the EMNIST dataset to containing about the handwritten letter characters from the file EMNIST letter 20 CSV like this and here. And I took this dataset from the EMNIST source on Kaggle, which is an extended version of EMNIST with additional alphabetic character. So I use the pandas library to read CSV file. Then I display the data size using df.save, and saw the amount of data was 3,085 rows and 785 columns. From this, we can see about the conclude that its rows is one letter image represent as a vector of 784 pixel values plus one label in the first column. Technically, the first column or df0 is the label of the letter, which is represent as a number from 1 to 60 to 26 because it consists of the letter A to Z. Meanwhile, the first to 784 column is a representation of 28 times 28 image pixels. Okay. In addition, I also important some important libraries such as NumPy for numerical computation, matplotlib for the letter image visualization, and sample from scikit-learn utils to randomize data so that there are the non-consecutive patterns that can affect the model training. Okay, let's see about the sample data. Why I make this program? So it's the program to randomize the order of the data using sample function from scikit-learn.utils with random state 42. So that the results are consistent and reproducible. It is important to do this so that the model does not learn based on the pattern of the data order. After that, I reset the index dataset so that I is back in order after being shuffled. Okay, next, separate label and features. After scrambling data, I separate the labels and the feature parts of the image. I took the label from the first column, like df.ilo 0, while I took the image data from the first to the 784th column, I received this image data to talk about size of 28 times 28 pixel so that it can be visualized and used in the subsequent image processing. Next, change label from 1 to 26 letter like A to G. So the original labels in this dataset are numbered from 1 to 26, which represents the letter I of A to Z. Therefore, I create mapping using dictionary compression, where the number 1 will be converted to the letter A to B, and so on until 26 becomes Z. I use the CHR, like 64 plus A, I, big function because in SCII code, the letter A start from 65. Finally, I convert all the numbered labels into an array of letters with the label card variable. This will make it easier to visualize and evaluate the classification result later. Okay, next we can see this step. So the first 7 images. So visualization of 7 sample letters from the dataset. At this stage, I want to display some sample letter image data from the EMNIST dataset. I use matplotlib and to visualize the first 7 images from the random dataset. Its image is displayed using plt.imsol with gray or grayscale color model because this data is a grayscale image of 28 times 28 pixels. I also display the label of its image above it using plt.titles like label or label chart and I here, so we can know what letter the image represents. For example, from this sample, we can see images that resemble the letter R, W, C, K, and so on, like F, D, and E. Okay, why is it important? This visualization is important to verify if the data we have is correct and model can be trained based on logical visual patterns according to the labels. It also helps us understand that handwriting characters can vary greatly, and this will be a challenge for classification model in the future. Okay, next, fetch 100 data per letter. So take 100 data per letter, like balance sampling. This is because the amount of data is letter in the EMNIST dataset is not balanced. I took 100 images for each ladder from A to Z. So there are 260 2600 data in total. This is important so that the trained model will not base towards certain letters that have too much data. I use the np.where function to find the index of image with a particular label and then took the first 100 using slicing like here. All index are then collected and used to select image and their label. Feature extraction HOG, histogram of orient gradients. Okay, the next step is to extract feature from the latter image using the HOG or histogram of orient gradient method. So this is the feature of HOG is often used in computer vision because it is able to capture its pattern, contours, and line directions that are very important in letter form. In this code, I use the schematics.feature.hog with parameters such as 9 directional orientation, a cell size of 8 times x pixel, and 2 times 2 blocks of cell. The result is the feature vector for its image, which will then be used as input to the classification algorithm. The result of this HOG are then stored in the HOG.features array and will become feature representation for the model to learn and to recognize handwritten letters. Okay, next, scalar. Scalar or data standardization. Before the data is used for model training, I standardize it first using standard scalar. The goal is for each feature in the data to have a distribution with a mean of 0 and a standard deviation of 1. This is important because algorithms like SVM are very sensitive to the scale of features. If not normalized, features that have a large scale can dominate the predictions result like this. Okay, next, SVM training and grid research with the split data. As you can see on my program, after standardizing the data, I divide it into training data and testing data, 80% and 20% respectively. I use stratify select labels to keep the distribution of letter balance in both subsets. For model training, I use SVM or supervector machine, as it is suitable for classification of high-dimensional data like this HOG feature. To get the best parameter, I use grid search CV to find the optimal combination of C, like gamma, and kernel parameter. I try C is 1 and 10 in gamma scale and 0.001 and kernel as a RBF. So the grid research result so that the best combination is C as 10 gamma scale RBF. So this combination is used for the final model. Okay, and the next is evaluation LOOCV. Evaluation with leave one out cross validation in this program. So after finding the best parameter using grid search, I process to the model evaluation stage. Here I use the LOOCV method. So LOOCV is a very strict cross-validation technique because in its iteration only the one data used as a test data, while the rest as training. This is very useful for small dataset so that all data is used for evaluation. SVM model setup based on cursors because or before evaluation, I make sure the SVM model has used the best parameter like C, gamma, and kernel from the previous research process. I also add checking whether the model has been fed before so that no errors occur when running. Okay, in this program, data sampling for LOOCV because the amount of data from each level is quite large. I only took the first 15 sample from each level using np.where because this is done to save execution time because LOOCV is very time consuming if the data set is correct. After the data is retrieved, I reset the data set of feature like X, LOO, and label Y100 not LOO to be evaluated with the LOOCV method. Okay, next, the final evaluation process with the LOOCV. This is the program run and evaluation. The next step is to run the final evaluation processing using the LOOCV technique. I use leave one out from scikit-learn model selection, where its sample will be the test data ones, and the rest will be the training data. For its iteration, the SVM model will be refit with the best parameters and then test on the one remaining sample. This process is repeated 520 times according to the number of samples. Storage and evaluation of results. During iteration, the prediction results are stored in YPRED-LOO and true label values in Y2-LOO. After all iterations are complete, I calculate evaluation metric including accuracy, precision, recall, and F1 score. I use average macro so that the evaluation is not that biased towards the amount of data from each class. So the final evaluation result of 520 LOOCV iteration saw an accuracy of 64.3600 precision of 65.33% and recall of 64.36% and F1 score of 64.50. The time taken to run all iteration was about 14.6 14.93 seconds. This so that the model is quite consistent in predicting. Also, there is still room to improve performance, especially in reducing false positive or false negative in some class. And next, calculating and displaying conversion metrics. After getting prediction results and the original label from LOOCV, I use conversion metrics from scikit-learn to create a conversion matrix. This matrix shows that number of correct and incorrect prediction for each class, like setting up labels and visualization. I use the letter A to Z as a class label because there are 26 labels in total that represent each disease or category in this dataset. And the creating confusion matrix heat map, I use seaborn.heatmap to display the matrix as a heat map graphics so that the value in the matrix are displayed as a number with blue-yellow coloring, make a difference clearer. Lines with and line color are added to make its box visible, and square to keep the box shape symmetrical. And titling and labeling exists. The chart title includes the overall accuracy in percentage format. So the result of accuracy score, like the X label, is the model prediction, and the Y label is the actual class. Okay, and the final view of the graph, I rotate the x-axis label for either the LED, like 45 degrees, and make sure all elements fit on the screen with tight layout. And finally, plot plt.show is used to display the conversion matrix heat map to the screen. So the LOOCV conversion matrix on the screen, you can see the overall accuracy on 64.36% here. All right, everyone. That's all my presentation about my processing data of computer vision. is the assessment mid-semester, and thank you for watching. I hope you can understand about my presenting, and sorry if I have bad words like the missing the words. Okay, thank you everyone. See you.